For this experiment, you will need approved eye protection, a vernier stir station with a stand, solutions of 0.1 molar sodium hydroxide, and an unknown solution of HCl plus an unknown solution of acetic acid. You will need a pH probe, a volumetric pipette with a pipette filler, a stirring bar, the LabQuest Mini interface, a 10 milliliter graduated cylinder, a reservoir with a drop nozzle, a drop counter, a clamp, and a computer that runs Logger Pro software. Start by inserting the stand into the stir bar base. Then clamp the drop counter onto the stand. Next, add the clamp to the stand. And then place the reservoir into the clamp so that its nozzle is over the hole in the drop counter. Transfer about 60 milliliters of the dilute base into the reservoir. Do this over an empty beaker for safety. Then open both taps and allow the base to flow through the nozzle to displace all the air pockets. Close them both. Place the reservoir back in its clamp with its tip over the hole in the drop counter. Next, take the Lab Mini, connect it with the small USB cable, and then plug the big USB cable into the computer. Take the other cable and plug that into digital 1 in the interface and the other end of the cable into the drop counter. Go to the computer, open Logger Pro, File, Open, and from the folder Advanced Chemistry, pick experiment 7B, acid base drop. Place a 10 milliliter graduated cylinder directly underneath the tip of the reservoir. Go to Logger Pro, go to Experiment, Calibrate, then choose LabQuest Mini Digi Drop Counter. Click the button for Automatic and press Start. Come back to the reservoir. Completely open the bottom tap. Now, slowly open the top tap so that 1 drop per second drops through the drop counter from the tip of the reservoir into the graduated cylinder. We're going to let this continue to flow until there are about 9 milliliters inside the graduated cylinder. On the software, you'll see that it is recognizing drops. When you have filled 9 or 10 milliliters into the graduated cylinder, measure its exact volume and then input that value into Logger Pro. This tells the computer what the average drop volume is. This is a graduated pipette. It's a volumetric piece of glassware, and we're going to attach a pipette filler to it. First, attach the rubber end into the glass of the pipette. If you squeeze valve A and then squeeze the balloon, you can produce a vacuum inside this pipette filler. By pressing button B, you will be able to suck up the liquid. Right now, we're putting 8 milliliters of dilute acid into the pipette. And then we're going to jettison 5 milliliters of that into a large beaker. This beaker already contains a magnetic stirrer bar, and then we're going to add 20 milliliters of water to the big beaker. That beaker then goes on the magnetic stirrer plate directly underneath the dropper. Remove the pH meter's protective flask. Then put the pH meter through the hole in the drop counter so that it touches the bottom of the beaker. Then connect the pH probe to channel 1 on the LabQuest Mini. Plug the stirrer into the mains and then switch the stirrer on so that the bar goes around as rapidly as it can but without hitting the pH meter. Then come to Logger Pro and press collect. You can see that the pH was already reading an acidic number. Go to the reservoir and open the reservoir so that I get 1 or 2 drops per second going through the drop counter. When drops start registering, you will record a pH trace. This is going to give us a graph of pH against added volume of base to a solution of acid. The sharpest part of the curve reveals the equivalence point. Keep collecting data past this point until the curve flattens out again. At this point, the titration is over. We can close that top tap and press stop on the data collection. The sharpest part of the curve reveals what the equivalence point is. Sometimes the human eye can spot that, other times they need a little help. You can go to page 2 to show the first derivative. Here, the turning point will reveal what the what?